Ideal gas goes through a cycle consisting of isochoric, adiabatic, and isothermal lines. B. Isobaric, adiabatic, and isothermal lines. With the isothermal process proceeding at the minimum temperature of the whole cycle, find the efficiency of each cycle if the absolute temperature varies and falls within the cycle. Solution. When the cycle is consisting of isochoric, adiabatic, and isothermal, as graph shown, process 1 to 2 is adiabatic, process 2 to 3 is isothermal, and process 3 to 1 is isochoric. Now we know that the work done will be only during adiabatic and isothermal process. This implies dW equals to P1 V1 minus P2 V2 divided by gamma minus 1 plus P2 V2 log V3 by V2. Also, according to question, T2 equals to T3 minimum temperature and T1 will be at higher temperature. Hence T1 by T2 equals to N. This implies T1 equals to NT2. Now heat added during process 3 to 1 dQ equals to CV T1 minus T2 CV into N minus 1 into T2 for 1 mole. Hence efficiency eta equals to P1 V1 minus P2 V2 by gamma minus 1 plus P2 V2 log V3 by V2 divided by CV into N minus 1 T2 equals to R into N minus 1 into T2 by gamma minus 1 plus P2 V2 log V3 by V2 divided by CV into N minus 1 T2 equals 1 plus P2 V2 log V3 by V2 divided by CV into N minus 1 into T2 equals to 1 plus RT2 log V3 by V2 divided by CV into N minus 1 into T2 equals to 1 plus R by CV log V3 by V2 by N minus 1. Now V3 equals to V1 and hence V3 by V2 equals to V1 by V2. Also P1 V1 to the power gamma equals to P2 V2 to the power gamma. This implies RT1 by V1 into V1 to the power gamma equals to RT2 V2 into V2 to the power gamma, or T1 by T2 equals to V2 by V1 to the power gamma minus 1. Hence V2 by V1 equals to T2 by T1 to the power 1 by gamma minus 1. Hence V1 by V2 equals to T1 by T2 to the power 1 by gamma minus 1. Hence eta equals to now 1 plus R by CV into N minus 1 into log V1 by V2 equals 1 plus R by CV log T1 by T2 to the power gamma minus 1 divided by N minus 1, since CV equals to R by gamma minus 1. B. When the cycle is consisting of process isobaric, adiabatic, and isothermal lines, as shown in the graph, process 1 to 2 adiabatic, 2 to 3 isothermal, and process 3 to 1 isobaric. Hence only changing is that the heat is added at constant pressure. dQ equals to CV T1 minus T2 plus P1 V1 minus V3 equal to Cp T1 minus T2, and work done dW P1 V1 minus P2 V2 by gamma minus 1 plus P2 V2 log V3 by V2. Hence eta equals to dW by dQ equals to P1 V1 minus P2 V2 by gamma minus 1 plus P2 V2 log P2 by P1. Since P2 V2 equals to P3 V3 and P3 equals to P1, again writing the equation for adiabatic process P1 V1 to the power gamma equals to P2 V2 to the power gamma, and hence finally solving all the equations we get eta equals 1 minus log n by n minus 1.